Ayan, so good morning everyone. Ang topic ko ngayon ay about sa delta Y delta connections under ng polyphase transformer connections. So familiar naman tayo sa delta Y na encounter na natin nung electrical circuits 2 natin. So hindi na to bago sa atin, pero ang pinagkaiba lang dito, ang delta and Y configurations is two basic forms of three-phase sources and loads appearing in industrial power systems are delta and the Y. A Y-connected device has its three elements joined at one common point in the middle. As such, the Y, alam niyo naman na itsura niyan. At yung delta naman has three elements joined as the sides of a triangle. So, ito yung delta. Pamilya tayo dyan. So, the voltage appearing across the terminals of each element in a polyphase device is called the phase voltage. Yan, yung voltage dito. Yan. And the current through each element in a polyphase device is called the phase current. Ito. Phase current yan. Voltage appearing between any two of the connecting conductors, ito, connecting conductors, yan, line na yan, yung nagko-connecta sa kanilang dalawa, is called the line voltage of the polyphase system. Line voltage. Yan. And the current through any of the connecting conductors is called the line current. Yan, yung kumokonekta sa kanila. Tawag dun is line current. Line and phase quantities relate to each other differently between delta devices and Y devices. So, line voltage for a balanced Y device exceeds phase voltage by a factor of 3, while line current for a balanced delta device exceeds phase current by the same factor. So, anong ibig sabihin yan? Ito lang yan. Para isama ito siya. So, sa system type naman, under ng Y, yung voltage line is equivalent sa square root of 3 times dun sa voltage, dun sa phase voltage. So, sinabi dito, sa Y device exceeds phase voltage by a factor of 3. Yan. Tapos yun sa current naman is the same factor. I line and I phase. And sa delta naman, samantalang sa delta, yung phase voltage is equal to, yung line voltage is equals to phase voltage, while yung sa current, yung line current is equal siya sa square root of 3 times din sa phase current. So, bakit vice versa sila? Bakit magkaiba? Explain natin yan sa sunod na slide. Yan. So, makikita nyo dito, yung line current is equal to phase current because currents are equal in series. So, itong connection na ito is naka-series sila. So, lahat ng dadaloy na current dyan is magkakapareho. And alam naman natin na pagkapag-series yung connection is same current. Samantalang dito naman, yung voltage line voltage is equal to the phase voltage because voltage are equal in parallel. So, ito yan. Yung phase voltage, magkakaparehas yan kasi. So, ito pa lang magagamit natin yung background na nalaman natin sa easy class natin. So, siguro sasabihin niyo mas madali na lang na kabisahin yung formula na ginamit natin kanina. Pero, gamit ito, representation na to, parang mas magiging malinaw yung kung ano nga ba yung connection nung sa three-phase system. Paano ano yung configurations nila at paano sila nag-work. Together. May 4 yan na magkakaiba. Delta delta, delta to y to delta, and y to y. So dito yung example na binigay natin ay y to delta. Yan. Ito another representation. Pero phase and line voltages are unequal in Y connected devices as are phase and line current. Ito, phase and line current in delta connected devices. In each of these cases though, we may see once again by visual inspection that this line and phase quantities cannot be equal because the line quantities are the result of two joining phase quantities. Ito, magka-join sila. In a Y network, line voltage is the series or the phasor sum of two phase voltage. In a delta network naman, yung line current is parallel phasor of the sum of two current summing at a node. So kapag alam natin yung system na balance yung kasi meron yung two types of balance and unbalance, mag-discuss siya next. So balance, we may assume that the multiplying factor between this line and phase voltages will be the square root of 3. So ito. Therefore, line voltage is square root of 3 times greater than Y phase voltage, and line current is square root of 3 times greater than the delta phase current. So ito na yung representation ng mathematical equation kanina na nakita nyo. So guys, tandaan nyo yung mathematical equation na yun at itong representation nila kung bakit nag-arrive dun sa mathematical equation na yun. Ito. So, pwede tayo mag-develop. We may develop a proper formula for calculating total power from line voltage and current by beginning with the formula described in calculating total power from the power of each resistor at the delta connected load. So, yung delta connected load is yung triangle, diba? So, ito yung power total is equals to 3 times the power phase. The P total is equals to 3 kasi nga yung P is equals to IV, so substitute natin yan, I phase and V phase. And so we may substitute line current for phase current and line voltage for phase voltage in this equation if we properly relate them for the delta connection, while the line voltage is equals to the phase voltage in a delta configuration. So ito yung itsura niya. Yan. Nakikita nyo naman yan. We may consolidate the two constants in this formula, 3 and the square root of 3, by rewriting the number 3 as the product square root of 3 times square root of 3, then cancelling one of these with the square root of 3 in the denominator. Yan. So, na-cancel siya dito. So, as a test, we may check to see that this new formula accurately calculates the total power of our balanced three-phase system. So, yung square root of 3 times dun sa line current, and dun sa line voltage. Mag-a-arrive tayo sa power na 3,456 na same dun sa nakuha natin kanina. Ito. Sana yun. Ito. Yan. So, BP is equal to BL over the square root of 3. Substitute na lang. Mag-arrive tayo sa sagot na ito. Tapos, gamitin natin yung ito. VP over VS is equals to return ratio. Then, paglaruan natin yung formula. VS is equals to VP times N2 over N1 is equals to 7967 times 43. Yan, substitute na lang. Correct. Tapos, mag-arrive tayo sa VS is equals to 159.35 kilovolts. Tapos, yung hinahanap natin na magnitude of the step-down voltage, ibig sabihin yung nandito, ito yung representation, is equal sa secondary voltage. Kasi nga, parallel sila. So, equal sila. So, para sa huling example, a power transformer rated 50,000 kilovolts ampere, 34.5 kilovolts over 13.8 kilovolts is connected Y grounded primary and delta on the secondary. Determine the full load piece current on the secondary side. So, una, illustrate natin yung sinasabi dito. So, ito yung voltage line, base voltage, secondary current. Yan, secondary. Ito. So, ang hinahanap naman natin dito ay yung base current on the secondary side. Ito. Base current. Ito, base voltage. So, gamitin natin yung formula ng sa may apparent power kasi may given na apparent power dito. Yung kVA. So, substitute na lang. Yung voltage sa secondary winding natin is given as 13.8. So, yun ang gagamitin natin. Substitute. Arrive dito. Then, para malaman yung base current sa secondary side, ito. Gamitin natin yung formula ng sa delta. Ito. So, IS equals to I2 over 0.3. Yan. Substitute, compute, and ito. Mag-arrive tayo sa sagot na ito. So far, sana naintindihan niyo yung sa delta Y connection and Y delta connections. So, tinakal ko yung mga possible na formula or yung mostly na ginagamit sa tuwing magkakaroon ng connection yung dalawa. So, that's all for today. Thank you.